Hello guys, trust you're doing fantastic. In today's video, we're going to be talking about the excess 3-code subtraction of 10's complement. And in today's topic, we're going to be considering the first case, subtracting smaller value from a larger value. Now let's go through the rules. 1. Take 9's and 10's complement and the excess 3 code for the subtrahend. Rule 2 says add it to the minuend excess 3 code. It means we're going to take the excess 3 code for the minuend. And let's look at what rule number 3 says. Rule number 3 says if carry is generated, shift the carry to the next bit with errors. Now rule number 4 states add 3 to the carry generated bits and subtract 3 from the bit without carry generated. The 5th rule says if carry is generated, there is no issue. If carry is not generated, then the result is negative. Alright, so let's take an example and see how we can apply these rules. Example number 1 says, what is the 10's complement excess 3 code? Subtraction of 634.21 from 842.25. So by solution, the expression is going to be 842.25 minus 634.21. So in this case, we are subtracting a small value from a large value. Alright, so in this case, this is the minuend and this is the subtrahend. Now the first thing we need to do is to obtain the 9's complement of the subtrahend. Alright, so to do that, all we need to do is to subtract each and every digit in this number from 9. So in that case, we're going to say 9 minus 6, which is 3, 9 minus 3, 6, 9 minus 4, 5, dot, 9 minus 2, 7, and 9 minus 1, that will give us 8. So once we have done this, remember what the rule says. It says we need to obtain the 10's complement of this result. Alright, so to obtain the 10's complement of this result is simply adding 1 to the result. So we have 365.78. All we need to do is to add 1 for it to achieve the 10's complement. So 8 plus 1 is going to give us 9. Then we'll bring down the 7 dot, we'll bring down the 5, bring down the 6, bring down the 3, and then we've achieved this new result. Then the next thing we need to do after obtaining this result is that we need to convert this result to excess 3 code. Now let's get the excess 3 code for this result. What we're going to do is that we're going to add 3 to each and every digit in this number. So we're going to have 3 plus 3, 6, 6 plus 3, 9, 5 plus 3, 8, dot, 7 plus 3, 10, and 9 plus 3, 12. So after obtaining the excess 3 code, the next thing we need to do, we need to convert this value to BCD. Now to convert this value to BCD, all we need to do is to represent each and every digit by a corresponding 4 bits in binary. So in that case, we're going to represent 6 in binary in its corresponding 4 bits in binary. So 6 is going to give us 0110, 9 is going to give us 1001, 8 is going to give us 1000, dot, 10 is going to give us 1010, and 12 is going to give us 1100. So in this case, we are done with this first part. So the next thing we need to do is to obtain the excess 3 code for the minute n. Right, so this is the large number that is subtracting the subtract n value. So we need to convert the minute n, we need to obtain the excess 3 code. Now obtaining the excess 3 code, we'll have to do the same thing by adding 3 to each and every digit in this number. So it's going to be 3, 8 plus 3, 11, 4 plus 3, 7, 2 plus 3, 5, 0.2 plus 3, 5, and 5 plus 3, that is going to give us 8. So we've obtained the excess 3 code for the minute n. Alright, so next, this result obtained needs to be converted to BCD. Alright, so to do that, all we need to do is to represent each digit in this value with its corresponding 4 bits code in decimal. So all we need to do is to say 11 is going to be represented in decimal as 1011, 7 is going to be represented as 0111, 5 is represented as 0101, dot 5 is represented as 0101, and then 8 is represented as 1000. So at this point, all we need to do is to add the BCD values for the subtract n and the minute n together. So the next thing we need to do is to carry out this operation. So this is the BCD for the subtract n, and then this is the BCD for the minute n. Alright, so let's carry on the operation. 0 plus 0, 0. 0 plus 0, 0. 1 plus 0, 1. 1 plus 1, 0 with a carry of 1 indicated in this red ink, and then we'll bring down the carry, which we have done here. Let's go over to the next segment of the bit. 0 plus 1, 1. 1 plus 0, 1. 0 plus 1, 1. 1 plus 0, 1. Alright, so no carries generated at this segment. So let's move over to the next segment of bit. 0 plus 1, 1. 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, 1. So no carries generated. Now let's go over to the next segment of bits. 1 plus 1 is going to be 0 with a carry of 1 indicated in red ink. 0 plus 1 plus 1 is going to be 0 with a carry of 1 indicated with this red ink. 0 plus 1 plus 1 is going to be 0 with a carry of 1. And then 1 plus 1 plus 0 is going to be 0 with a carry of 1. Now this carry is brought down, as you can see. So this part carry is generated. Now let's move over to the next segment. 0 plus 1 is 1. 1 plus 1 is 0 with a carry of 1. So 1 plus 1 is going to give us 0 with a carry of 1. 0 plus 1 plus 1 is going to be 0 with a carry of 1. Now we bring down the carry. Now this is called n carry. Now the n carry is generated. In this case, we have to discard it. Remember, in our previous video, we usually add it to the first segment of bit, but in this case we're not going to do that. All right, so we're going to cancel this. It's not going to be done because the rule says if carry is generated, we have to discard the carry at the end. So if we have n carry generated, we have to discard this, so there will be no point adding it to this part. All right, so in that case, but the other segment that has generated carry, we need to shift it to the next bit. So the carry generated from this segment is shifted to this other segment. We have this carry shifted, and then the carry generated in this part, this segment, we shifted it, okay, to this other segment. So we're going to sum it up. So in this case, this part has nothing to sum up with, so it's going to be 0 because we're not going to be utilizing this. So this is going to be 0, this is going to be 0, this is going to be 1, and this is going to be 0. All right, so the next thing we need to do is to sum up this part. So it's going to be 1 plus 1, which is 0 with a carry of 1. So 1 plus 1 is going to be 0 with a carry of 1. 1 plus 1 is going to be 0 with a carry of 1. 1 plus 1 is going to be 0 with a carry of 1. So we bring down the carry, which is this. Right, so carry is generated again in the segment. Alright, so let's go to the next part. Since we have nothing to add, we bring down this part 1, bring down this 0, bring down this 1, bring down this 1. Moving to this other segment, there is nothing to add. We bring down the 0, bring down the 0, bring down the 0, bring down the 0. Now let's move to the other part, which is the last segment. So we have to add 1 to this part. So it's going to be 1 plus 1 is going to be 0 with a carry of 1. 0 plus 1 is going to be 1. Now bring down the 0, bring down the 0. So we have noticed that we have a carry generated at this point. So it means we have to shift this carry to the next segment of bits. So we have to repeat the process all over. So if we have carry, if we keep generating carry, we have to continue adding until there is no carry generated in all of the segments. So in this case, let's carry out this addition. Now in this part there's nothing to add, we'll bring it down. This part there's nothing to add, we'll bring all the zeros down. Dot. Now we need to carry out this operation. So we say 1 plus 1 is going to be 0 with a carry of 1. 0 plus 1 is going to be 1. No carry generated. We bring down this 1, we bring down this 1. And then this part, nothing to add, we'll bring down everything. We'll have all the zeros. Then this part, nothing to add, we'll bring down all 0, 1, 0, 0. So at this point, no carry is generated. So at this point, we have the result. So the next thing we need to do, we need to add 3 to the segment that generated carry, and we need to subtract 3 to the segments that do not generate carry. So we're going to add this to the bit. So this is used to correct, for correction purpose. Now this part, if you notice, this part actually generated carry. Right, so this part generated carry, which is the first part. So we need to take note of this part. Carry is generated in this part, so therefore we need to add 3. Now this part also generated carry. Right, so we need to add 3. Now this part did not generate carry. Also at this point no carry was generated, so therefore we need to minus 3. Okay, so 0, 0, 1, 1 represent 3. Dot. Now let's check. This part did not generate any carry, but at this point carry was generated. So since carry was generated at this point, so it means we need to add 3. Then if we check this other part, we notice carry was also generated at this point. Though it was not generated at this point, but it was generated at this point, so therefore we have to add 3 to it. Right, so that's why we've added 3 to this part. Alright, now so let's perform the operation. So let's go. So we have this, which is 0, 0, 1, 0, which is nothing but 2, and this is 3. Now you can easily go a shortcut. 0, 0, 1, 0 gives us 3. This is 2 rather, and then this is 3. So 2 plus 3, well, actually the result is going to be 5. So we're going to have 0, 1, 0, 1, which is 5. This is 0. This is 3. So 0 plus 3, this will give us 3. So the result is going to be 0, 0, 1, 1. So if you carry out the addition, you're going to get this result. So this is a shortcut on how to do this. Right. So this is 1, 1, 1, 0. So this is 8, 4, 2. So this gives us 14. Alright, so this is 14, this is 3. So if you say 14 minus 3, that is going to give us 11. So this will be 1, 0, 1, 1. So this is going to give us 11. Now if you carry out the subtraction, you're going to get the same result. Now point. This is 0, this is 3. 0 plus 3, we're going to get 3. So it's going to be 0, 0, 1, 1. Okay? And then the final part you have 0, 1, 0, 0. So this is nothing but 4. Now this is 3. So 4 plus 3, we're going to get 7. So it's going to be 0, 1, 1, 1, which will give us 7. So this is the shortcut how you can do this. So at the end of the day, we've gotten 5311.37. So since n carry is generated, the result is positive. Now if you remember, initially at first n carry was generated, that was discarded. So since n carry was generated, so this result is going to be positive. Alright. So in that case, we're going to have 5311.37. Now if we have to subtract 3 from 5, we're going to get 2. If we subtract 3 from 3, we're going to get 0. If we subtract 3 from 11, we're going to get 8 dot. If we subtract 3 from 3, we're going to get 0. If we subtract 3 from 7, we're going to get 4. So in that case, 5311.37, which is this 5311.37, is nothing but the SS3 code of 208.04. So this result is nothing but the SS3 code of this result. So this is how to solve a question in 10's complement 3 code subtraction. So if you've gotten to this part of this video, it means you have gained sufficient knowledge in 10's complement 3 SS3 code subtraction. Alright, so I'm going to encourage you to pay attention to the subsequent videos in this channel. Alright then, enjoy this video.